announcement to all of you. So, in today's session, ma'am will revise the concepts from week 5 to week 8. Okay, so it's instructions to all of you. Please do not ask any general doubts or any doubt from our assignment. Okay, so please just focus on just a revision part only. Rest of the general doubt or any assignment doubt we can discuss in our sessions. Okay. Hope this is clear to all of you. Thank you.
Yeah. Yes, thank you, Prashant. Thank you very much, sir. Thank you, Prashant. Am I audible?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Okay.
Yes, ma'am.
Yeah. Good evening, everyone. And I happened to see the chat in which Rahul has said that he has not completed week 7 and week 8. Will this session be good enough? I don't know what you mean by good enough or bad enough, but as a teacher, this is only a revision section. Okay. And yes, I'm going to teach, assuming that you all have already watched the videos. This is not any fast track or any session where I'm just going to give you some important questions and you read only this and then you're good enough. That's not the intention of this session. The intention of this session is to just provide you with a revision of the contents that are for the week. I will not be handling any questions regarding any specific assignment questions or anything that has been specifically asked for grading purposes. Okay, right? These are the questions I'm not going to handle. If there are any conceptual level questions, then I would definitely handle them. Okay. In the interest of time, I just want to lay a few rules before we this one. I don't want interruption in terms of audio. So I would request all of you to please check that you have your this one muted. Okay. And if there are any questions, you may please use the chat box, or you can unmute yourself, but and ask the question after I finish talk, not while I am talking. Okay. And there are certain rules to be followed even in the chat box. Remember that everything here is being recorded. Okay. So please follow some tact and diplomacy. This is an academic session. We are not in a stand-up comedy show or anything of that kind. So I'd request you all to please follow basic rules, which I don't think I'll have to spell it out. I hope I'm clear. Is it all fine?
Yes,
okay, this is an academic
ma'am.
session. This is not a stand-up comedy show. Okay, right. Thank you all. Okay.
Ma'am.
So, yeah. Yes,
Ma'am,
please.
I have a doubt in statistic question, ma'am.
Is it about permutation, combination, or probability?
Ma'am, it is combination, ma'am.
So let me finish teaching the thing. I have not yet started. If there are any questions with what I'm addressing, please stop me at that point of time. I'll wait for questions, and please have the questions when I wait for questions. I'll give you question time after every topic. Is that clear? I think
Yes.
that way it would be more organized. Is
Yes,
it okay?
Yes, ma'am. It's clear.
Yes, ma'am. Okay, yes, so that is the thing. I'll give you question time after every topic I am going to address. So at that time, you please call this one, right?
Okay, ma'am.
The first, what we are going to do today is we are going to start, and this is just going to start with the basic principle of counting. By basic principle of counting, again, I repeat, this is just a revision of the contents that has already been given to you. Okay, I'm not going to go through every detail, but I'm just going to revise the most important concepts. Even before we deep dive into knowing about permutation and combination, and the reason why we are teaching permutation and combination in a statistics course is permutations and combinations and the principle of counting play a huge role in understanding probability. Okay, so that is the reason why we are introducing the notion of permutation and combination. And to understand permutations and combination, we need to understand what are the basic principles of counting. When we talk about basic principles of counting, there are two basic principles of counting. One is what we refer to as the addition rule of counting, and the other is what we refer to as a multiplication rule of counting. Now, typically when it is an addition rule of counting, if an action can happen in n1 different ways and b in n2 different ways, the total number of ways of the occurrence of A or B, I'm making it very clear here, it is A or B, it is n1 plus n2. That's why it is called addition rule of counting. Whereas if an action A can occur in n1 ways and another action B can occur in n2 different ways, the total number of ways, and they are sequential, the total number of ways of the actions of A and B together is n1 into n2. Now, this is the basic difference between addition and multiplication. Is addition is action A or action B, whereas multiplication is action A and action B. And I just repeat the example that I have chosen in the class, where I said that if you have two pants and if you have to choose between 3 pants and 2 shirts, okay, if you're choosing a shirt or a pant, you can choose a shirt in 3 different ways, a pant in 2 different ways. So if you're choosing a shirt or a pant, it would be 3 plus 2, 5 ways of choosing. Whereas if you have to choose a shirt and a pant, you're combining each of the shirts with 2 possible choices of a pant. So it will be 3 into 2, 6 ways. So that is the first fundamental difference that you need to answer is, okay, if you want to have a shirt, as I said, after every topic, I will wait. You please note down your questions and ask me at that point of time. Okay, right. So if it is a multiplication rule, it is A and B, whereas if it is a addition rule, it is A or B. This multiplication rule, which is A n1 into n2, I can actually extend it to R actions. Suppose instead of just 2 actions, suppose again, go back to this example. Now I want to choose a shirt and a pant. I'm going to extend it to a shirt and a pant and a sweater. Perhaps I have 2 choices of sweater. Then it's going to be 3 into 2 into 2. There are 12 ways of doing it. So the generalization of the multiplication rule is, if there are R actions to be provided and each one has an Ni way of doing it, the total number of possibilities of doing all these R actions together is N1 into N2 into Nr. This multiplication rule plays a huge role in defining what is the factorial notation. Again, I repeat and I request all of you to please mute your videos. Please. Thank you. So the definition of this factorial is, suppose I have n boxes to be filled, I can do the first in n ways, I can do the second in n minus 1 way, third in n minus 2 ways, so far. So the number of ways I can do all of them together is n into n minus 1 into n minus 2 into 1. And this is denoted by this notation, which I call a factorial notation. And by convention, 0 factorial is equal to 1. Now, this is what we have so far. So at this point, I'm going to stop. If there are any questions on the basic principles of counting, I would request you all to use the chat box, please, because if everybody starts talking at the same time, then it's going to be chaotic. I'll address questions on basic principles of counting, the addition rule, the multiplication rule, and the notation factorial. If there are any questions, I give 2 minutes. Please use the chat box. If there are no questions, we'll go on to the next topic. Okay, there is one question about what is simultaneous. I don't know what is the prompt on screen, please. I don't understand what do you mean by prompt on screen. Simultaneous is nothing but doing things at the same time. Non-simultaneous is doing things not at the same time. Okay, I don't know what you mean by prompt on screen.
Excuse me, ma'am.
Yeah.
Ma'am, can you give an example like both the addition and multiplication rule is applied simultaneously?
See, the addition rule, as I said, if you have to choose a shirt or a pant. Okay, are you able to see my screen?
Yes, ma'am.
Yes,
Yeah.
ma'am.
So when you have to choose a shirt or a pant, there are 3 shirts available to you and 2 pants available to you. Okay, I'm asking you to choose either a shirt or a pant. So how many ways can you choose a shirt?
3 ways.
How many ways can you choose a pant?
It is 2 ways.
So how many ways can you choose either a shirt or a pant?
It is 5 ways as for the 3
5
plus.
ways, yeah. So it depends. You cannot have a rule where you cannot have a situation where you are applying both the addition and the multiplication together. Here, the context is I'm choosing a shirt or a pant. Now I'm asking you to choose a shirt and a pant. So how many ways can you choose that? I can either choose a yellow shirt with a black or a blue pant, or orange shirt with a black or a blue pant, a green shirt with a black or a blue pant. So this is 3 into 2. That is what I say by a multiplication rule. Is that clear?
Yeah, ma'am. Thanks.
Okay, that is the difference between a multiplication. So if you're using a or, it always comes as addition. If it is, when you're choosing 2 chocolates from a choice of 7 dark, we have not yet come to combinations. Please, I would ask you to please keep the questions regarding combination till we pass it. This discussion is related and restricted to the addition and multiplication rule of counting. Okay. A non-simultaneous event. I do not see, I'm not going to talk about events still, but suppose you are actually, what you're doing is, I'm first choosing a shirt and then I'm choosing a pant, then it is not simultaneous. Okay, but if I'm choosing a shirt and a pant together, it could be at the same time. Simultaneous is always at the same time. Okay, non-simultaneous is not at the same time. Suppose I'm tossing a coin, I see it is head, then I roll a die. Okay, so tossing a coin and rolling a die are not done simultaneously. But suppose I'm tossing a coin and rolling a die at the same time, they are simultaneous. Okay, yeah, right. So I'm going to go to the next topic, which is permutation and combinations. Okay, so we first start with the notion of what is a permutation. Permutation is nothing but an arrangement. Okay, so when we talk about permutation and why is the need to learn about permutation? There is a need to learn about permutation because we are finally, when we are computing probability, we are doing some sort of an arrangement, or we are trying to see how many different ways these things are arranged or combined. Okay, so when we are looking at the permutation, basically we are trying to count. Again, that's why we went back to the basic principles of counting. We are trying to count here. A permutation is an ordered arrangement of all or some objects. I repeat, a permutation is an ordered arrangement. What do we mean by an order? Always remember, when I talk about a permutation, the order is extremely, extremely important. Okay, Prashant, can you just turn off the videos of everybody, please?
Yes, ma'am.
Yeah, please. Thank you. Please turn off the videos because it keeps coming and going and it's very distracting. Thank you. Okay, so when we talk about permutation, you can see in the formula what are important is when objects are distinct. So let's look at 3 distinct objects or 3 distinct people. Let me call them A, B, C. How many ways can I arrange them? First of all, I'm talking about a linear arrangement. I can either have A, B, C, or I can have a BAC, or I can have a BCA, or I can have a ACB, or I can have a CAB, or I can have a CBA. Okay, so these are the possible arrangements. They're distinct objects because A is distinct from B is distinct from C. So these are distinct objects. Now, if I allow repetitions, okay, then I can have the object A is also allowed. Suppose I have 3 places to be filled and I have 3 objects. I can put a here, A here, A here. Or I can have, so for example, I'm generating numbers, then 1, 1, 1 is a possible thing. So I'm allowing 1 to be repeated. So this repetitions is allowed. It comes when you are forming a password. When you're forming a password, you're allowed to repeat numbers. So the number of ways you can generate passwords, it comes under. So whenever you're looking at a question, you need to understand the context in which it is being asked. Suppose I'm asking for a password, then I know that I'm looking at how many ways can I arrange these numbers such that repetition is allowed. Okay. Right? Is it clear?
Yes, ma'am.
Right. So now, what is a permutation? So in a permutation, so if I have, suppose R objects, okay, and I want to know the number of distinct permutations of this R objects from n distinct objects. So suppose I'm looking at 2 objects and I just want to know I have 3 distinct objects, say A, B, and C. I'm looking at the distinct number of permutations of the 2 objects. So I can either have an AB or an AC, a BA or a BC, a CA or a CB. These are arrangement. Even though this is the same, you can see that BA and AB and BA, AC and CA, they are the same. So this number of distinct objects, that is what we denote by NPR. What does that mean? The first one, I can put any one of the n objects in the first blank. If I have put any one of the first objects in the first blank, repetitions are not allowed. Okay, I'm not allowing any repetition here. So the first thing is I'm not allowing repetition. So the minute I have put the first object, then I have to choose for the second blank from the remaining n minus 1 objects. For the third blank, I have n minus 2 objects. Similarly, I keep going. For the rth blank, I have n minus r plus 1 or n minus r minus 1 objects. Now, what does ordering mean? For example, suppose I have 2 blanks and I have 3 objects, say A, B, C. I'm not allowing repetition. If I fill the first with A, what are the choices for the second one? I can either have a B or a C. So the first one, I could either have a B, or a C. If I fill it with A, for the second one, I have a B or a C. If I fill it with B, I have a C or an A. If I fill it with C, I have either a or a B. So the total number of ways I can choose, this is AB, AC, BC, BA, CA, and CB. What is the meaning that order is important? See, even though this has only A and C, here A is occurring before B. The arrangement A is before C, and here C is before A. These are distinct arrangements. That's why I say when the order is important. Okay. So when would you use this? Suppose I'm looking at ranking people. Okay. Either A is getting the first rank and C is getting the second rank, and C getting the first rank and A getting the second rank. They are different. The order is important. So permutation of R objects where I'm not allowing repetition is what the first thing that is called NPR, which is nothing but n into n minus 1 into n minus r plus 1. How did I get this formula? I multiplied this numerator with n minus r up to 1 factorial. The denominator is also n minus r factorial. So NPR is n factorial by n minus r factorial. So this is the first important formula that you need to know is the number of possible permutations of R objects from a collection of n distinct objects. Repetitions are not allowed is given by NPR. So NP0 is 1, NP1 is n, NPn is n factorial. But what would happen if repetitions are allowed? And this is the case where, see, this application is when you want to know how do I arrange 3 people, because I cannot have the same person occupying 2 places. Okay, I want to know how many ways can I choose the first rank, second rank, and third rank. That is, so there is an arrangement there. Whereas suppose now I am interested in knowing how many ways can I generate a password. In this case, repetitions are allowed. I am allowing. So you could have a password 1221, where I have this 2 and 1, which are repeated in 2 places. Okay, so in this case, I want to know how many ways can I have this number of arrangements. The first one can be filled with any one of the n. The second can again be filled with any one of the n. Third can again be filled with any one of the n. And the rth can also be filled with any one of the n, to give the total number of distinct permutations from n distinct when a repetition is allowed to be n to the power of r. Okay, Prashant, can you just mute everyone? I think there is something which I'm able to hear somebody's audio. Okay, thank you. Okay, I again repeat, I request everybody to please mute themselves. Okay, this is for the benefit of everybody else. We have about 370 people who have joined, and I think everybody has joined here to gain something. Okay. Which formula is this, ma'am? See, NPR is n factorial by n minus r factorial. And how did we get this? Suppose I have r places without repetition. The first can be filled in n, second can be filled in n minus 1, third in n minus 2, the r in n minus r plus 1 ways. Now, this is the same as n factorial by n minus r factorial. But however, if repetitions are allowed, the first I can have n choices, second also I can have n choices, third also I can have n choices, rth also I can have n choices. So I have in total n to the power of r choices. Remember, in all these cases, we have only the multiplication rule that has been applied. Okay, so let me give you an example. Suppose I have 3 people and I want to arrange 2 of them at a time. What is n here and what is my r here? I have 3 people. I want to see how many ways can I arrange 2 at a time. N equal to 3, r equal to 2, right? And how many ways can I arrange? Will it be n to the power npr or will it be n to the power of r? I have 3 people. It would be NPR because I cannot have one person who is choosing this one. Now I have 5 numbers and I have to create a 4-digit password. How many ways can I do it? I have to choose from 5 numbers. I have to create a 4-digit password. How many ways can I do it?
5p4.
Is it 5p4 or 5 to the power of 4? I can repeat any number. I have 5
5
numbers.
to the power 4.
5 to the power 4.
Okay, so that is the difference. Even if the number is a 0, I am allowing 0 to be one of the things. So where you need to understand. So when I have written 3 people and 5 numbers, in one case I was allowing repetition, in one case I was not allowing repetition. The context was the same. Why can't it be 4 to the power of 5? Now, are you asking a question just for asking, or is there any meaning behind it? Why should it be 4 to the power of 5? How many ways can I choose the first number? 5 ways. Second number, again 5 ways. I just have a 4-digit password. My n equal to 5. The first, I have to choose a 5-digit password. How many ways can I choose the first one? 5 ways. Second 5, third 5, fourth 5. So it's 5 to the power of 4. Okay. I have
this is
a
with
request
repetition,
here.
right?
Yes, this is with repetition. I said I'm allowing repetition. I just have a request to all of you. This is not teaching from basics. This is a revision session. I am going to revise the concepts. So for those of you who have not gone through the videos of week 5 to 8 and has some problem here, I would request you to please go back, see the videos, and then come back and ask in the forum if you have still clarification. Okay? This is not the easy way out. I will not watch any of the weak videos. I'll just attend a revision session and I'll ask my questions. That will only derail the process for everybody else. I think this is fair enough. Is that clear? Have I made myself clear?
Yes,
Yeah?
ma'am.
Please do not assume that
Yes,
I will
ma'am.
not watch anything and then I'll just come here and ask whatever I want. I think that is unfair. This is a revision session. Please understand that. Okay? Right. I'm sorry, I have to be tough because there are 422 people who have enrolled and I cannot derail the session for one or two. Okay? Thank you. Thank you for your understanding. Okay? That's why I said, I'm sorry I'm not being polite, but I have to take the stance.
Number of
I'm not being impolite. I'm not being rude also, please.
Of one kind and very few.
I'm not being rude also, okay?
Number one is of P1 is of one kind. P2 is of
Nishikeet, please mute your mic, please.
I just want all of you to understand there are 400 people who have logged in, okay? And I cannot be teaching everything right from beginning. That is all I try to say, okay? Nothing more than that.
Okay.
Okay? Right. Thank you. Thank you for your understanding. Okay. Now, when the objects, so Papa ki pari. Now, I do not know how to understand, react to these things, okay?
You
I
could just
told you
mute
that
everyone.
Ma'am, you
see,
can
we
disable the
wanted.
chat, ma'am, in settings so that people will stop.
Yes, hello, ma'am. hello,
Like
hello.
we are,
One
ma'am,
second.
you are doing, ma'am, you are doing like revision session.
Yeah, hello
So
everyone. Hello. Yeah, so this is Prasant. Okay, so if ma'am told lots of time, if you are not going to follow these kind of things, so we will mute to everyone and ma'am will simply revise the content and we can leave. Okay, so we have given the permission. You can unmute yourself, so that doesn't mean you will disturb the class. Okay. So please maintain the standard of the class. Okay.
Thank you all. Okay. We are losing time. I agree we are losing time. And this is the first time I'm having such an uncooperative class. I must tell it. Okay, please. I have done so many live sessions before. This is the first time I'm finding people who are disrupting the class. And I think at the risk of calling myself impolite and rude, I'm going to continue by being rude. I'll only answer questions which are relevant to the topic. Okay, right. Now, the next thing is the earlier two things, be it when I talked about NPR, where I was choosing R objects from N distinct objects, repetitions not allowed, and N to the power of R, whereas arranging R objects from N objects, okay, right? I always assumed that I had N distinct objects, right? But when I don't have N distinct objects, for example, you would have come across a lot of problems where I'll say that, okay, how many types can I have? I have here, if you look at the word statistics, I have 3 S's, I have 3 T's, I have 2 I's, I have 1 A and 1 C. So in this case, how many permutations, how many ways can I arrange these objects where I have P of one kind, P2 of another kind, P3 of another kind, okay? So may I again request that the chat messages can please be only with respect to the content that is being talked here. I know there are wonderful videos on YouTube which will teach much better than what is being offered here. I would request some discipline be followed in the chat. Otherwise, we'll have to disable both the chat and mute. And this is not going to be helpful to anybody. Can we have some discipline? And Prashant, from next time, only people who are having an online degree can join this class, okay?
Yes, sure, ma'am.
They have to have an online degree so that I know I put a name to that person who is spamming.
Sure, ma'am. Sure. We can
Okay?
track. Yes.
Yeah. We need only people with registered email IDs to join the live sessions. Not anybody can join it. Okay? Right. So the number of ways of permuting, it's already half an hour and we have not even finished one proper topic. The number of ways of permuting n objects where P1 is of one kind, P2 of another kind, and Pk is n factorial by P1 factorial, P2 factorial. This is the formula. Now, in which kind of problems do you apply it? For example, I would have asked for statistics. One of the most famous thing is again population. You can see here again in population, I have 2P, I have 2O. So when I don't have distinct objects, but I have some objects of the same kind. So in statistics, I know that they are totally 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 words. I have 3 S's, 3 T's. I have 1 A, I have 1 C, I have 2 I's. Okay. So the total number of ways would be n factorial. N is 10 divided by 3 factorial, 3 factorial, 1 factorial, 2 factorial, and 1 factorial, which is this number. Okay. So one of the, again, very popular examples is Mississippi. You can find that in many of the books. They will have asked you how many ways you can do it because you have multiple repetitions. So when objects are not distinct, you have this formula which you'll have to apply. Okay. So this is about linear permutation, or when I have the things are arranged in a line. Okay. First thing was we looked at linear permutation. Objects were distinct, but repetitions not allowed. Linear permutation, objects were distinct, repetitions allowed. Linear permutation, where the objects are not distinct. Okay. The repetitions under this one. Now we go on to non-linear or circular permutation. Now in a circular permutation, the whole idea is if I fix one of the particular items, okay, for example, if I fix A, then I have a B, C, D, okay, I fix A, I can either have a B, C, D or a C, D, A or a D, B, A. I have this way, I fix this, then you can see that this is the number of ways of getting the arrangement. So here again in circular permutation, there are two key things you need to understand. One is whether the clockwise and anti-clockwise are same or whether they are different. If the clockwise and anti-clockwise are different, then I am just fixing one of the items, then I know among the other I can arrange them in n-1 factorial ways, because we have already seen in linear arrangements that the number of ways of arranging n items among themselves is n factorial. So if I fix one item, I have n-1 remaining, and that can be done in n-1 factorial way. However, if the clockwise and the anti-clockwise are same, then it is going to be nothing but n-1 factorial by 2. These are the two critical concepts of circular permutation that you need to understand. Okay. So when we talk about permutation, what are the key things? One is when objects are distinct, repetitions are not allowed. Objects are distinct, repetitions are allowed. Permutation when objects are not distinct. Circular permutation when clockwise and anti-clockwise are the same and are different, and when they are same. I wait for 2 minutes. If there are any questions, please post it on the chat box. I'll answer.
Ma'am, distinct means?
Distinct is if I have A, B, C, they are different and distinct. Okay, but if I have an A, C, I have two of them are same. Okay.
Okay,
Hello, ma'am.
Yeah.
Ma'am, good evening, ma'am. Ma'am, could you please explain the clockwise thing with an example?
suppose I'm having people sitting in a round table. I have 4 people sitting in a round table. How many ways can they sit?
4 minus 1 factorial.
3 factorial, right? Okay. Now I have 4 color of beads. How many ways can I put them in a mala type? Now anti-clockwise and clockwise are the same.
3 factorial divided by 2.
Okay, so in the context, you can look at the context and then you can decide whether the clockwise and anti-clockwise are the same or they are different. Is that clear?
Okay, ma'am. Thank
Yeah.
you.
Yeah, ma'am, got
Any more
it.
questions? Yes.
Hello,
Yes,
ma'am.
Rudransh. Yeah.
Hello, ma'am.
Yes,
If
Rudransh.
the
Yeah.
if the things are all identical, then only there is one way of arranging them in a circular, na?
If they are identical, yes. If they are not identical, because in a circle, what do you mean? Because see, what do you mean by identical? Suppose I have 3 green beads. Okay, how many ways can I linearly arrange them? Forget about anything else.
And 3 green, if they are identical, then there is only one way. And if they
Yeah.
aren't, then
They are
the
identical.
permutation.
There's only one way, right?
Yes,
And
ma'am. Then in
what
the
have you used here? What have you used here? So, which
Ma'am,
formula have you used there? What
no,
is your
ma'am,
n here? What is your n
that
here?
n
It
is
is 3,
1 or
right?
3. Yes, ma'am.
3. And how many are of the same kind?
Ma'am, all.
All the 3. So
Yes,
what is
ma'am.
the formula? What is your n factorial by p factorial?
Yes, ma'am. But in the weekly mock for 5 and 6 and question number 13, in the note there written the
I
keys
told you
are identical.
already. Pardon? I told you already there is something very specific about a question. I don't have access to that question here. Okay.
Oh,
If
okay,
these are
ma'am.
okay, so I cannot answer any specific question, but this is what, yeah. Okay.
Excuse me,
What do you
ma'am.
mean by partial? Okay, let me ask you 2 red beads and 1 blue bead. Okay, how many ways can I linearly arrange them?
3 ways.
3 ways. 3 ways.
3 factorial
3
upon
ways.
2 factorial.
2 blue and 1 green.
3 factorial upon 2
Linearly.
factorial.
3 ways.
3 ways.
3 ways, what are they? BBG?
BGB, GBB.
So this is 3 factorial by 2 factorial, which is 3 ways. How many ways can I circularly arrange them?
1 way.
What is it?
2 factorial.
Ma'am,
One
GBB.
way.
2 ways.
No, is it 2 factorial or 1?
Ma'am,
Two
n minus
ways.
1
No,
factorial.
don't.
1 factorial.
2 factorial.
Now
n minus 1 factorial.
I'm arranging them in this one. So what would be is GGB? I'm arranging them in a circle, right?
One way.
Ma'am, there is only
It would
one
be
way.
same.
One way.
Only
One way.
B and G are the same,
Clockwise and-
right?
Yes, ma'am.
Clockwise and anti-clockwise are the same here. So
Yes,
given
ma'am.
the context of the problem, you understand whether clockwise and anti-clockwise are the same. Is that clear?
Excuse me, ma'am. Like,
Yes, ma'am.
if
Yeah.
we are, if within the objects we are arranging in a circular manner, if there are
Hmm.
repeated objects, so how we could like
Isn't
arrange
that
it?
what I have done here? I'm giving you 2 blue beads and 1 green bead.
Yeah.
And I'm asking you to arrange in a circle. How many ways can you do that?
That's n minus 1, which is 2 factorial.
Is
But
it 2 factorial? No, is it 2 factorial? Clockwise and anti-clockwise, are they same here or are they different?
It would be 2
No, they are
factorial by 2
different.
factorial.
Sorry, can you please repeat the question?
2
Is it
factorial divided by
clockwise
2
and
factorial.
They're same.
It's an anti-clockwise
One way,
method.
ma'am. One way.
it's 1 way, 2 factorial, right? N minus 1 factorial by 2. Where the 2 ones among them, it is just a blue bead and a blue bead, right? Is that clear?
Okay. Okay,
Yeah.
so it doesn't
And always
affect whether the
identical.
objects are repeated or not, isn't it?
Yeah, here I'm talking about beads. Agreed?
Yeah, beads. Yeah,
I'm
yeah.
talking.
Yes.
So they are repeated. So whether So the way you can understand it, put this B1, B2. Whether it is B1 or B2 here, if it were B1, B2 and G, then how many ways would you have arranged them? Clockwise and anti-clockwise are same.
Then it becomes n minus 2 factorial by 2, which is one way.
Pardon?
It becomes, did you say clockwise and anti-clockwise are the same?
Yes. Yeah.
Then
it
it
is again
becomes
one way. If they are different,
one way. Yeah.
Okay,
If they are
so you should
different,
understand.
if they are different, it becomes two ways.
Yeah, it is two ways. So that's what I want you to understand, that what is the way you do it. But however, if this B1 and B2, okay, are the same, whether it is B1, B2 or B2, B1 are the same. So you need to understand how you're doing it. Whether it is clockwise or anti-clockwise doesn't make a difference here. Is that clear?
Ma'am, I have a question in it.
Yeah.
Ma'am, if
Yes,
like
please.
B1 and G1 and then B2, so ma'am, how we are gonna solve it?
No, what I'm trying to say is, see, you look at GB1 and GB2, GB2 and B1 appear to be different. Is that clear? But in actuality, they are the same. So that's why you're dividing it by 2. Do you get it?
Yes, ma'am.
Yeah.
Yes, ma'am. Yes.
That's why you're dividing it by 2, right? Because within them, B1, B2 or B2, B1 are the same. Is it clear?
Yes, ma'am.
Yeah, ma'am. But
Okay,
in circular, ma'am. But in circular, suppose one arrangement we can do it B. Suppose I will go with anti-clockwise, so it will be B, then B, and then G. Okay, one combination can happen. Then another combination we can do it G, B, B. So two combination it can be possible, right?
No. See, this is G, B1, B2. Okay. Or G, B1, B2. These are the two combinations possible. If anti-clockwise and clockwise are the same, are different. Would you all agree? But between B1 and B2, there is no difference, right? Just for notational convenience, I put B1 and B2. Because B1 and B2 are the same actually, right? Blue beads. Is that clear?
Yes, ma'am.
Ma'am, it's clear.
They're not distinct. That's what I'm trying to say. Is it clear?
So, ma'am, the answer will be 1.
Yes, the answer is 1.
Right, ma'am. Okay, thank you.
Right.
Ma'am, what if we have more beats, like just for
extend the logic. Just extend the logic. So you divide it by this P factorial, right? Suppose just extend the logic. I have 1 green, 2 blue, 2 white. Write down with W1, W2. Then after W1, W2 among themselves can be modeled. Suppose I had G, B, B, B. Then how many ways can I do it?
6 ways.
One way
One
only.
way.
One way.
Perfect. 1 way in circular.
Yeah, circular. So
Yes,
you
ma'am,
try
one
it
way.
out, right? I'm just asking you to try it out. Don't
Ma'am.
understand the concept that way. Is that clear?
Yes, ma'am.
Ma'am.
Okay. Yeah.
A, B, C, D are different. That's why there is 6.
Yes, that's why I mean by distinct, and when they are not distinct, between themselves you have ways of arranging. You'll have to divide it by that. That's what I try to say. See, why did we have this formula here? Because these P objects among themselves can be arranged in P factorial ways. Okay?
Okay, I understand.
Right. So now then, this is the concept of the permutation. Now, see, many a time we come across questions that when should we use a permutation and when should we use a combination? And that is what I'm going to try and clarify now. Suppose I have 10 people and I have to choose only 3 people. Okay. The minute I say choose 3 people, the order is not important. I just have to choose 3 people from 10 people. Then what do? I choose these 3 people from 10 people. I have 10, choose 3. But now suppose I'm asking you from these 10 people, choose a president, a vice president, and a sports secretary. Then will you use a permutation or a combination?
Permutation.
Because when I'm talking about permutation, but when I'm saying that just make teams of 3, it would be a combination. So From the context, you understand whether the order is important or whether the order is not important. Is that clear? Okay, so let's look at a few questions here. Okay, so in permutation, order always matters, combination order does not matter. A password consists of 7 characters, okay, where in a password, does the order matter or not?
Yes, ma'am.
Yes, matter.
So would you use a permutation or a combination? Order matters in a permutation.
Order doesn't matter in a
That's clear.
password.
Order matters in a password, right? Okay. Now in a pizza parlor, okay, you are asked to build your own pizza. I give you a choice of 10 toppings and you'll have to, in fact, I'm sure many of you would be using Swiggy and Zomato apps, you'll see that all this build your own combo is there. Choose 2 starters from 5 starters. Okay. Mains, choose 2 mains from 5 mains and things like that. So in this build your own pizza, I'm asking you to choose 5 toppings from a list of 10 toppings. Does the order matter here or it does not matter?
Does not matter.
It doesn't matter. So would you use a combination or would you use a permutation?
Combination.
It's a combination. Okay, right. 4-digit PIN code. In all our mobiles, we need this. It matters, right? Permutation. A bookshelf has 8 different books. I want to arrange 5 books. How many ways can I arrange it?
Permutation.
8p5. But I just want to choose 5 books.
Combination.
Always the key thing you need to understand whenever you're looking at permutation and combination is whether the order matters or whether the order does not matter. If the order matters, go in for a permutation. Within a permutation, look at whether the objects are distinct, whether you're allowing repetition, because in a passcode, I can allow repetition, but in some cases, you see many a time people will say that the passcode should have one special letter, it cannot start with a special letter. So in that case, you need to understand how many ways of doing different things, whether they are different repetitions are allowed or not, whether it's a circular permutation, within a circular permutation, whether it is clockwise or anti-clockwise. These answers will come from the context of the question. Is it clear? Yeah?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So with this understanding of permutation and combination, we move on to the next thing, which is probability. Okay. Now, okay, let's have a few more things. If a team member, roles, position, order of selection matters, that is choosing a team leader, presenter, and coordinator, you choose permutation. This is again said. So in the first question is, how many ways can a committee of 4 members be selected? Would you use permutation or combination?
Combination.
Just combination. The second is, I want them to hold specific positions.
Permutation.
It will be a permutation. Now, if you look at the Olympics is happening now, okay? Right? After every heat, if I want to choose only the 3 people, okay, I'm choosing the first 3 people.
Permutation, ma'am.
I'm choosing the first 3 people.
And combination.
Any 3. I'm not choosing any 3. I'm choosing the first 3 people.
Permutation.
Combination.
I have 5 people. Okay, let me tell this.
Second best, third best. So it is
I'm
permutation.
choosing first 3, okay? But when I'm choosing the first 3, suppose A, B, C are the first 3. This BCA and CAB, this all will be, I want you to understand it from that context. It is both a permutation and a combination in some sense. Is that clear? I have 8 people running. I want to choose 3 people. Is that clear?
Got it.
Got it?
Yes.
Think about the question. Just think. I want you all to think a bit and then apply. That's it. Okay. It's not tough at all. Just think and apply. Okay. Right. 4-letter
Ma'am,
code.
that means both the result will be same.
Yeah, see, suppose 8 people, suppose 5 people are choosing A, B, C, D, E. Okay. I want you to tell me that this is one order of finishing the race. I'm choosing the first 3 people. Okay. I'm choosing the first 3 people. How many ways can I arrange these people?
5 factorial ways.
So permutation.
5 factorial.
So I
5
need the
P3.
first 3,
ways.
I need this one.
5
Okay.
P3.
If I'm choosing any 3, it would be a combination, but I'm choosing only the first. So the minute I have an order, okay, see, within these 3 people, whether I'm choosing A, B, C first or B, A, C, but I'm choosing, so these 2, okay, the number of ways A, B, C and B, A, C, they're all coming. Why should Christina request remote control of my choose? No, I'm not going to approve that. Okay. Is that clear? Okay. So you just, the best way to understand is enumerate and understand whether order plays an important role or not. Okay. Now I'm
So
forming
it's a combination in permutation.
In a sense, but the number of ways A, B, C, D, E, this is one way. B, A, C, D, E is also another way, but the way I can choose the first 3 people, this is one way, this is one way, but since both of them give me the same result, okay, A, B, C. So if I specify how many ways are A, B, C selected, in that case, you know that A, B, C can be, both of them give me the same result. It is not 2 ways, it is only one way. Is that clear?
Yes, ma'am. Clear. Yes, ma'am.
Yes, got it, ma'am.
So again, go to the question, understand what is the question. Yeah.
Then we have to apply combination.
The
First we
first
have
is,
to do permutation, then we have to go with
yes,
combination.
and then, yeah, the first is you find out how many ways people can be ranked. Okay. Now I'm asking among these A, B, C. Okay. In how many ways will A, B, C occupy the first 3 positions? You can find that out. Is that clear? I have 5 people running the race. How many ways will that? All of them would give me only finally how many ways will A, B, C occupy the first position? Will be selected. That is what I was the question. But the first thing I did a permutation. The second thing for selection, I said, okay, A, B, C being selected, even this A, B, C are going to be selected. Agreed? Even this A, B, C are going to be selected. Is that clear?
Yes. Considered as one.
Okay, not 5C3. See, one request to all of you is don't blindly just look at applying the formula. Okay, among these 5P3 ways, how many ways does this ABC are appearing is what I want you to understand. Is that clear?
Yes, ma'am. So would it be the total number of ways of arranging it divided by the number of ways of arranging each set internally?
In a sense, yes. In a sense, I'm just, see, first of all, I want you all to just go back and think about it. I have 5 people participating in the race. Okay. People.
Good evening, ma'am. Actually,
turn off your mic.
Among the 5, if we choose 3 randomly, then this is a
then it is 5C3.
Yeah, this
It's
is
a
a combination. But
it's
if
a combination.
we rank them, if we want to
I'm
rank
ranking
them,
them. See, the question is different. I'm ranking them. It will be 5P3 ways. But among this, I'm saying in how many ways are ABC selected? It could be different. I'm just telling that is different. Is that clear?
Yes, ma'am.
Yes, ma'am.
Yes.
Yes, ma'am, it's clear.
I don't understand.
The combination part too, after where you have written the
See, I have 5 people participating in a race. Okay. How many ways can I order them? 3. I'm choosing the first 3 positions. How many ways can I do that?
5 choose 3. 5C3. 5P3 actually. 5P3.
Because I'm choosing the first 3. Okay.
Yes.
What I'm saying is among these 5P3, okay, the ABC will occur. Okay, this is A is first, B is second, C is third.
Yes.
Yes, ma'am.
A is first, C is second, B is third. Right. So there are, this is BAC. So these all, among these 5p3, there is only one way all ABCs are chosen. That's what I'm trying to say. Is that clear
Yes,
now? Yeah, that is what I wanted to tell.
Ma'am, in the end,
But
after
the answer is 5p3. You choosing first.
5p3 is the total number of 5p3 is the number of this one. I'm not saying
Arranging
if
first.
they are going. Yes, arrangement. It
But-
is 5p3 only. Yeah.
But what is the answer? Answer
What
for
answer?
this
I'm not
question.
giving you any question for answer. 5p3 is the way of arranging A, B, C, D, E in a race. Okay. I said that among these 5p3, what is 5p3?
Arranging first three people.
And the number of arrangement of 3 from 5.
Number of arrangements of 3 people or the 3 toppers, right? In
Yes,
this, I said among these 5p3, I want to know how many ways can ABC. Only ABC, I am looking at the number of this one in which ABC have been chosen. That's what it's another
5C3.
question. It is, okay, that what ABC is chosen is not 5C3. See, I can choose 5C3 ways, okay? But among these 5p3 ways, I'm seeing whether A has come first, B has come second, and C has come third, or A, C, B. All of them are the same things for my combination part. Whether I'm just for me, after a second part, this does not matter. Okay. Just that is what I wanted you all to understand. I'm not applying a 5p permutation or if I want an order matters, it is permutation. Otherwise, it is combination. Okay, that's all I want.
Second half, will it be 3C1?
Let's move forward. I think we are just, I think I have
Yes,
probability. If there are any specific questions, you please ask it in the discussion forum. Okay, I'm sorry, I have to stop here. Right. So the next thing is I want to focus on probability. Now, with understanding what is a permutation and combination, why do we need to learn probability? Probability is basically, the first thing is, we live in an uncertain world. We need to understand how to handle this uncertainty. What do we mean by uncertainty? The biggest part is, suppose I am conducting an experiment. Okay. And I know that if I add, say, 10 grams of sugar and 10 grams of salt and mix them together in water, I'm going to get a result. Now, suppose another person does the same experiment, controlled experiment in same situation, the answers or the results could be the same because there is no uncertainty in the outcome. If I'm giving exact amount of sugar, exact amount of water, exact amount of salt, and in a controlled way, asking them to mix it together, I can expect the same outcome. However, to 2 different people, if I give a coin and ask them to toss it, even in the control state, what could happen is both of them might not give the same outcome. Would you all agree with me? If I give 2 people, same, identical coins. The reason is the first one, I did not have any uncertainty in the outcome. There is a big difference between outcomes known and outcomes uncertain. In the second case, when I'm tossing a coin, I know the outcomes of the experiment. What are the outcomes of the experiment? It would be a head or a tail. What is happening is there's an uncertainty in what will be the outcome. It could be a head or it could be a tail. So basically, that is what is called a random experiment. So we start by defining what is a random experiment. Random experiment is an experiment whose outcome is not predictable or whose outcome is uncertain. Is that clear? So that is a random experiment. Now the outcomes. Now what all constitutes a random experiment? Tossing a coin, rolling a die. You're starting from your house at a particular time. The time you reach another destination. Is that a random experiment or not a random experiment?
Random
Are you always sure that you'll reach in 15 minutes?
Random.
It is random. Right. Now, you throw a dart on a dartboard, that arrow on a dartboard. Is it a random experiment or is not a random experiment?
Random experiment.
Are you always
No,
sure
it's a
that you
random.
know where it will land?
Random.
So
It's
you
not a
know, but you
random
know it is
experiment.
going to land
No, ma'am.
somewhere, but where it is exactly going to land, you do not know. The outcomes are uncertain. Okay, so you can see that whenever I have a random experiment, I need a framework to handle this random experiment, and probability theory helps me to handle this uncertainty through constructing defining what is a random experiment and defining what is a sample space, which is a collection of all basic outcomes. So if I toss a coin, the sample space is head and tail. If I toss a coin twice, the sample space is head, 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 tail, tail, head, tail, tail. If I toss a coin till I get a head, I'm going to toss a coin till I get a head. So what would be the sample space? I'm repeating the experiment.
Infinity.
What would be the sample space? What are the set of all possible outcomes? I'm
Ma'am,
going
2 to
to
the power
toss a
n.
coin till I
It
get
could
a head.
end at head only. If we get head on the first chance, then it is over.
Then what would be the what is that the only outcome?
No, ma'am. Then
Second
tail
try.
head.
No, ma'am. You
Tail
will
head.
tails
Tail.
also. We have
Then
two.
tail head. Tail,
2 to the power n, ma'am.
Okay.
Then it goes on like this.
What is 2 to the power of n
The
here?
sample space is not infinite.
What is 2 to the power of n here?
4.
I do not know. I can keep getting only tails till I get the final head.
It's infinite.
Okay.
Sample space is
Right.
infinite.
Is this clear? What are the possible
ma'am.
outcomes?
Yes.
Okay. So
Yes,
these.
ma'am.
So the first thing is, what is the collection of all possible outcomes is what I call the sample space. Now, once I tell what is a sample space, there are two things that we need to understand. The possible outcomes should be mutually exclusive. Can I have? May I request everybody to please mute themselves? Thank you. So when I talk about basic outcomes, I know that the basic outcomes, I cannot have a head and a tail happening at the same time, right? Okay. So they have to be mutually exclusive and they have to be exhaustive. That is, I've listed all possible outcomes. Okay. Can anything else happen other than head and tail? Can any other outcome happen?
No, ma'am.
No, ma'am.
No, ma'am.
Second
No,
case
ma'am.
also, these are the possible. So that is what I mean by exhaustive, and they are mutually exclusive. Okay. So the minute I define a sample space, these are what we refer to as building blocks of probability. Then I have what I defined as events. Okay. Now, event is nothing but a collection of all basic outcomes. So let's define these events in a better way. Again, toss a coin. What is the sample space here?
Head and tail.
Head and tail.
Tossing two coins. Head, tail, tail, tail. Okay. Right. Now, what is the event head on the first toss? So this is going to be HH and HT. Right. Let me define another event, which is head on the second toss. Again, this is HH. Right?
HH and DH.
Head on the first or second toss. Remember, it is first.
Three cases.
This is going to be head can be here. Okay. This is nothing but even union E2. Remember, whenever I talk about or, it is a union.
Union.
Head on the first and second toss.
Even intersection E2.
HH.
HH, which is even intersection E2. So you can see that I can define a lot of events. So this is the way, suppose I have I have children, I have girl, girl, boy, boy, girl, boy, girl, girl, okay, boy, boy, and things like that. So many of the problems are modeled on this tossing of two coins, two children family, then how many events is the girl child the eldest, girl child the youngest, and you would have seen problems of this kind modeled on tossing the coin. Okay. So now if I look at this, I have defined what is union of events and what is the intersection of events. What is important to notice when I talk about or, it is a union. When I talk about and, it is an intersection. Now, one very important thing is, again, go back to sets. What are the set operations? I know union, I know intersection, I know complement. So what is a complement? So what is a complement of this set E1? How would it describe the complement of this set E1?
Ma'am, universal set
Even-
minus the even set.
No, don't go to set there. I'm saying describe it. Even
And
is
that
head on the
this
first
won't
order.
happen. This will not happen. Except this everything.
What would it be? It would be tail on the first toss, right?
Tail. Yes, ma'am.
TH and TT.
Right. It is tail in the first toss. Similarly, what is the complement of E2?
Tail on the second toss.
Tail on the second toss. So
Tail on a second
rather
toss.
than looking at it from a completely mathematics perspective, it would always help you to describe these events, okay, right? So that it will help you to understand it in a better way. Always describe the events, right? Okay. So what is a null event? A null event is an event without any outcome, right? So can I have an event where head and tail appear on the first toss?
No.
I cannot, right? Okay. And you can see that if the intersection of E and F is this one, null event, then E and F are said to be disjoint. So I cannot have both a head and a tail on the first toss. So they are said to be disjoint. Okay. So we can see that we have here the same taking the tossing of that coin twice. I have described what are the complements of the events. Now, once we have described the complement of the event, the next building block is what we call subset. For example, again, the event on the first toss is HHHT. Event of a head in both the toss is HH. You can see that E is a subset of F. That is, the event that head appears in both the tosses.
Ma'am, can you
Yeah.
explain the disjoint event using the first example, please?
Okay. See here in this example, okay. Now, what is the event head and the tail in the first toss? E3. What is the TH? TT. Can E1 and E3 occur simultaneously? Can a head in the first toss and tail in the first toss happen simultaneously?
No.
So what is so they are mutually exclusive, right? Or they are disjoint. Is it clear? So what is E1 intersection E3? It's a null set. Yeah.
Null.
Yeah. It's a null set, right? So that's what I said. If E and F cannot simultaneously, I cannot have a head on the first toss and tail on the first toss happening simultaneously. So they are called mutually exclusive or disjoint events. Is it clear?
Yes, ma'am.
Yes, ma'am. Right. So the next thing is subsets. Okay. So if you look at it, this event head in both the tosses is a subset of head on the first toss. And we'll understand why the subsets are important, because when we talk about subsets, why are we doing through the sub theory? Because I want to give what are the probability of these events happening. In other sense, I want to know what is the probability that the outcome is a head, or what is the probability that the outcome is a tail, or what is the probability that when I toss a coin twice, I'll get a head on the first toss. So in order to do this, we go to what we call the axiomatic approach. Before going to the axiomatic approach, we illustrate this entire sample space as a universal set, because it's a set of all basic outcomes, and the events as subsets. So here you can see I have two events, E and F. They are not disjoint, they have an intersection. And I can see that here I have two events, E and F, which are disjoint, they don't have an intersection. Here I see E is a subset of F. Okay. So the next thing is I need to know how do I allocate, or how do I give the probabilities for these events. And what the axiomatic approach for probability says is you consider an experiment whose sample space is given to you for any event. I know event is a subset of the sample space. We are all clear about this? Yeah. I have
Yes,
the
ma'am.
sample space.
Yes,
An
ma'am.
event is a subset of the sample space. For any event of the sample space, the probability of that event is a number between 0 and 1. That is what the first axiom says. Okay. Can it be 0? Yes, because a null event would have a probability 0. The probability of the sample space is 1. And the third says that if I have a sequence of mutually disjoint events, then the probability of the union is the sum of the probabilities. This is for countably many. Another way of looking at it is, suppose I have two events which are mutually disjoint. The probability of the union is the sum of the probabilities. Everything else we derive from this axioms. For example, what is the probability of the null set? I know probability of the sample space is 1. What is the null set? Null set is a complement of this. Agreed? Yeah.
Also called impossible event.
Agreed, ma'am.
Yeah, it is also the impossible event, right? It is the null set. So probability of the null set is also 0. Okay. So from here we can, yeah.
Ma'am, the probability can be either 0 and 1, or ma'am, can it lie between 0 and 1, like 0.5 or something like
It
that?
would lie between 0 and 1. That's what this says. I never said it would
That's
be
it, like,
either 0 and 1. It is a
okay,
number
ma'am.
between 0 and 1.
Okay, ma'am.
Okay, it I never said it is 0 or 1. It lies between 0 and 1. Okay. So the third axiom, I can write it for finite union also, which is probability of E1 union E2 is the sum of the probabilities. So what happens when I have the general thing? So you can go through your notes. You can see that the probability of the complement is 1 minus probability of E. And from that, I get probability of the null set is 0. Now, a very important rule in probability is what we call the addition rule. Now, what is the addition rule? A third axiom says that if E1 and E2 are disjoint, probability of E1 union E2 is probability of E1 plus probability of E2. This is what the third axiom says. Now, what happens if E1 and E2 are not disjoint? So when E1 and E2 are not disjoint, I have an E1 here, I have an E2 here, and I have an intersection here. Is it clear? Okay.
Yes, ma'am.
So let me write this E1 union E2 as A, B, and C. Okay. What is this A? A is this portion, B is the intersection portion, and C is the other portion. Now, what can I say about A, B, and C? Are they disjoint?
No, ma'am. No, ma'am.
A, B,
No.
and C. A, B, and C.
No, ma'am.
A is this portion.
Yes, ma'am. A, B, and C.
Yes, ma'am. A, B, and C are
A, B, and C, are they
Yes,
disjoint?
they are mutually
I have
exclusive.
just written even, they are disjoint, right? Would you all agree that A union B union C is the same as E1 union E2?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yes, ma'am.
Right? So probability of A union B union C is same as probability of E1 union E2?
Yes.
Yes, ma'am.
From a third, this one, what is axiom? A, B, C are disjoint. So what is probability of A union B union C? If I apply my third axiom, A, B, C are
Probability of A
disjoint.
plus probability of B plus
It would be
probability
probability of A plus probability of B plus probability of C. Agreed?
Yes, ma'am.
Yes, ma'am.
Okay. But B is nothing but E1 intersection E2, right?
Yes, ma'am.
Yes.
Yes.
Yes,
What
ma'am.
is A? What is A? Region A is E1 minus E1 intersection
E2.
E2, right? And
Yes,
C
yes,
is E2 minus
Yes,
E1
ma'am.
intersection E2.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Agreed. So this probability of A plus B, C is nothing but probability of E1 minus probability of E1 intersection E2, okay, plus probability of E2 minus probability of E1 intersection E2 plus probability of E1 intersection E2, which I'll get as probability of E1 intersection E2. Is this clear?
Yes, ma'am. Clear, ma'am.
Yes, ma'am.
Yes, ma'am.
So this is what we call as the addition rule. And this rule will apply. Suppose I had E1 intersection. When I have 3 events, what would happen? How would I extend that? I'll have another event. So you can see that this is the total intersection, right? So you'll have addition, and so this is called principle of inclusion and exclusion. What are you including and what are you excluding? But for the purpose of this first course, this rule is what we need, which says that the probability of union of any two events is the sum of the probability minus the probability of the intersection. Now, if they were disjoint, what would happen? What is the probability of this if they were disjoint?
Zero.
So it is nothing. What is probability of even union E2 there?
E1 plus E2, probability of E1 plus probability of E2.
That was what we started with, right? If E1 and E2 are disjoint, then the probability of the union is nothing but the sum of the probabilities. Is this clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Right?
Yes, ma'am.
So this is what we refer to as the this one. So now let's apply this probability, this addition rule. Okay?
Excuse me, ma'am.
Yeah, please go ahead.
Ma'am, yeah, can you please explain that A is equal to E1 minus E intersection?
See, now I have,
Previous. Yeah.
this is my E1 and this is my E2, right? This portion is
Yes,
what
ma'am.
I'm going to write as A. Okay? This
Yes, ma'am.
portion is what I'm going to write as B. And this
Yes, ma'am.
portion is what I'm going to write as C. What is here E1? E1 is A union B, right?
Yes, ma'am.
Right? So what is
Yes,
A?
ma'am.
B is nothing but A intersection B, right?
Intersection
So what
B.
is A?
Yes, ma'am.
A is nothing but E1 removing A intersection B, E1 intersection E2, right?
Okay, ma'am. Okay, ma'am.
So similarly C. Do you get it?
Yes, ma'am. Yes, ma'am.
Okay, that's
Thank
how
you,
I
ma'am.
did it. Okay?
Okay, ma'am. Thank you, ma'am. Thank you.
Right. So now suppose I'm going for shopping again, shirt and pant. I go to a clothing store. I'll purchase a shirt with a probability of 0.3 and a pant with a probability of 0.2. And I'll purchase both a shirt and a pant with a probability of 0.1. Okay. What proportion of customers purchase neither a shirt nor a pant? What is the probability of what is the probability of S, where S is the event that the customer purchases a shirt? What is given to us? Probability of S is
0.3.
0.3. Very good. What is probability of P?
0.2.
0.2.
What is the probability that a person would purchase both a shirt and a pant? And in terms
0.1.
of S and P, it is S intersection P, right?
Intersection.
And what is that?
0.1.
That is
0.1.
What is the chance that a customer will purchase either a pant or a shirt?
0.4.
Complement of this.
0.4.
That is probability of S union P, which is 0.3 plus 0.2 minus 0.1, which is a 0.4. Agreed?
Four.
What is this?
Yes.
This is the probability that a
minus
person will
0.4.
purchase either a shirt or a pant. But that is
Yes.
not what I'm asking. I am saying neither a shirt nor a pant. So it is a
0.6.
complement of
0.6.
6. Complement of 6.
1 minus
So
0.4.
1 minus 0.4 is
1
equal
minus
to
0.4, which is 0.6. Is that clear? So
Yes, ma'am.
if you
Yes, ma'am.
break down problems into understanding what is being asked, it becomes much easier. Don't deep dive into formula. Just write down the steps. It will become easier for you. Is it clear?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Clear, ma'am.
Yes.
Right.
Yes, ma'am.
Yes, ma'am.
Okay.
Ma'am, not understand, ma'am.
What did you not understand?
That
What
third,
did you not understand? Which one?
This
What
is-
third?
that complement.
third?
That
Okay,
Neither
tell me
a-
what is the probability with which a person can buy a shirt or a pant? It is S union P.
Yes, ma'am.
So neither a shirt nor a pant, what would it be?
Complement. It's
That's
complement.
it. So what is, that's it. That's the answer.
Yes, ma'am.
Okay.
Ma'am, ma'am,
Yeah. Yes,
one
please.
doubt, ma'am. S union P means both S and P, no, ma'am?
Yeah, S and P is either a shirt or a pant. S union, both a shirt and a pant is what? That is already given to you. That is S intersection P, right?
Intersection.
Intersection is A and B. Union is A or B.
Okay, ma'am.
Is it clear? Always union is S, A or B. Intersection is A and B. Is it clear?
Yes, ma'am.
ma'am.
Yeah.
That's also what to write when either is written in questions.
either A or B is always a union.
Union.
A and B is a intersection.
Intersection.
Is that clear? Right? Now I've asked neither a shirt nor a pant. So this is the
It's a complement.
complement of the union. Is that clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Now there are experiments where the outcomes are equally likely. What do we mean by equally likely? For example, if I toss a coin, unless it's a coin from the movie Sholay, I am always sure that there is getting a head or a tail. It's equally likely. I could get a head or a tail. If I roll a die, I would always get 1, 2, 3, 4, 5, or 6, unless it is some die which is loaded, like the one in Mahabharata, if you all are aware of Mahabharata. So when I have equally likely outcomes, then the chance or the probability of each outcome happening is given by 1 by n. So you can see when I toss a coin, the probability of head appearing is the same as the probability of tail appearing. I have only 2 outcomes, which is 1 by 2. When I roll a die, probability of 1 appearing is the same as probability of 2 appearing, which is the same as the probability of 3, 4, 5, and 6, which is 1 by 6. And this is when we refer to as equally likely outcome. Okay. Now, if A is denoting the event that the outcome is odd, then what is the probability of getting an odd number when I'm rolling a fair dice?
1 by 3.
1 by
3
2.
by
1 by 3.
3 by 6. 3 by 6 is
1 by 2.
3 by 6.
1 by 2.
1 by 2, ma'am.
right. 1 by 2. Okay. It is just 1 by 2. Outcome is greater than 4. Strictly greater than 4.
2 by 6.
It is
2 by
2 by
6.
6.
1 by 3.
Okay.
2 by 6.
It is either odd. So now you tell me, somebody asked the question, what would we do when it is either? So are A and B disjoint here?
Yes.
Are A and B,
No.
are A
No,
and
no,
B
no.
disjoint?
No, 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 no.
No, ma'am.
No, right?
Five,
So what
five
is
is
the,
common.
so now I'm asking what is the probability of C happening? It is either odd or greater than 4. So C is nothing but B union, A union B.
Yes, ma'am.
Minus
4 by
Now
6.
add
2 by
the,
6.
apply the
2 by
addition
3.
rule.
2
It will be
by
1 by 2. 1 by 2 plus 2 by 6 minus
A intersection.
1 by 6.
what?
1
That
by
would be
1
1
by
by 6. Is that clear?
Yes, ma'am.
Yeah. So how do you apply these rules
Yes,
to
ma'am.
problems? So here I've asked an either. So you can see that it is a 3 by 6 plus 2 by 6 minus 1 by 6, which is 4 by 6, which is 2 by 3. Is this clear, please?
Yes, ma'am.
Yes, ma'am.
Applied the addition rule. Okay. So the first thing is understanding what is a random experiment, the notion of a sample space, notion of event, then the probability axioms and the addition rule of probability. In the addition rule of probability, we need to understand probability of even union E2 is probability of E1 plus probability of E2 minus probability of E1.
E1 intersection E2.
Remember, if it is an OR, it is union. Okay. And
Intersection.
it is an intersection. Any questions?
And what is meant by extractive?
Pardon?
Extractive.
I did not understand. Can you please type it out?
Can you explain how probability of sample space is 1?
Probability that I'm saying that the probability of sample space is 1 because I know for sure that at least one of the outcomes will happen. That's what it means. Okay. I'm sure because it is actually mutual. I'm sure that one of the outcomes will happen. I said that it has to be exhaustive. I know that one of the outcomes will happen. That's why the probability of sample space is 1.
Our favorable outcome is entire sample space only, ma'am. So probability equals to sample space
That's
upon
what I'm saying.
total.
I'm sure that one of the outcomes is definitely happen. That's why the probability of the sample space, that one of the outcomes is definitely going to happen. So probability of S is equal to 1.
Why it can't take the value of 2 or 3 something more?
No, this is an axiom. We have said that the probability of this axiomatic approaches says that probability would lie between 0 and 1. Okay? Right?
Ma'am, how can we get this PDF that you're sharing to us?
Yeah, I think Prashant will take care of that. Okay?
Okay.
We can
Mutually
explain.
exclusive and disjoint are the same.
We can explain that question, ma'am, why the probability is between 0 and 1 only, because the total sample space will always be greater than denominator part will always be greater than the numerator. So the value in that case will be always between. Yes, ma'am.
See, the axiomatic approach does not look at a numerator or a denominator. It says that because I know for sure something from the sample space will happen, I am just setting that probability of sample space is equal to 1. And
Yes,
probability of any event which is a subset of the sample space is going to be lesser than that. So the probability of any event would lie between 0 and 1. Okay, that's
always
how it
less, ma'am. Yes, ma'am.
Yeah. Okay. Right. The next important thing is, yeah.
Can you please bring that question again, in which first we had to apply permutation and then combination? Actually, I had to ask.
No. Please, I have to go. I think conditional probability is an extremely important topic. I just have about half an hour left with me. Okay.
Okay, all right.
Yeah. Right. So conditional probability is the next thing. So if you have any specific questions, I repeat, for people who have specific questions, please write it to Mr. Prashant. He will discuss it with me and get back to you. I think we are running out of time, and I think there were a lot of questions in conditional probability and independent events. I'll spend the remaining time in trying to explain this. Okay. So what is the notion of conditional probability? So many a time what happens is we would want to know what is the chance of something happening given some extra information. What does this mean? So let's go back to tossing a coin twice, HH, HT, TH, and TT. Okay. Now, what is the chance of me getting a tail in the second toss?
HTTT.
So now, if I go back, the event is HT and TT. Okay. So the chance of this event happening is 2/4. But suppose now I give you some information. And what is that information? Suppose I give you the information that the first toss was a head. Okay. If I give you the information that the first toss was a head, then what are the outcomes of that event? It is HH and HT. Is that right?
Yes,
now
ma'am.
I'm asking,
Yes,
what
ma'am.
is the chance of you finding a tail in the second toss, given the first toss was a head? I'm giving you some extra info.
HT.
It is
HT.
again only this thing, HT, but it will be 1/2, right? So let me explain this through a notion called probability trees. Okay. So now if I have a toss, I'm tossing a coin once. Okay. This is the experiment. I toss a coin once. Are you all able to see the PDF?
Yes, ma'am.
Yes, ma'am.
Only two outcomes.
Yes,
I have
ma'am.
listed these two outcomes. Now, if I toss a coin twice, okay, you can see that the first toss is a head and a head. The second toss is a head, tail, head, tail. This is the first toss. This is the second toss. Is that clear?
Yes, ma'am.
Okay.
Yes,
Right. What is the chance of getting a head here in the first toss?
1/2.
1/2.
What is the chance of getting a tail? 1/2.
1/2.
The chance of getting a head in the second toss, given I had a head. Again, if you only look at the second toss, the chance of you getting a head here is half, a chance of you getting a tail. But what is the chance of you getting a head, given you had a head in the first toss? It's going to be 1/4.
1/4.
It will again be 1. This is head and tail, again 1/4. Again, head in the second toss and tail in the first toss, 1/4. This is again tail in the second toss and head, it is 1/4, 1/4. Is this clear? The chance of this outcome happening, which is a HH, HT,
Yes, ma'am.
HT. Is it clear?
Yes, ma'am.
What is the chance of you getting a tail in the second toss, given you had a head in the first toss?
1/4.
1/4.
It is 1/2, right? No, no, no. No, no.
By-
Listen to me carefully. Tail in the second toss. Given you had a head in the first toss. What is the chance of that?
1/2.
1/2. What is the chance of you getting a tail in the second toss independently? It's also 1/2.
Yes. 1/2.
Yes, ma'am.
Yes.
Right? So this event of getting a tail in the second toss is independent of whether you had a head or tail in the first toss. Both of them are 1/2. Is it clear?
Yes, ma'am.
Yes, ma'am.
Now let me do the same thing wherein I have a bag with 4 white and 3 black balls. Okay. What is the chance with which I can pick up a black ball?
3/7.
3/7.
Ball?
4/7.
4/7. So the first thing is they are not equally likely. Is that clear? Earlier the
Yes,
head
ma'am.
and tail, they were equally
Yes.
likely. Okay. Now if I pick up a black ball, okay, I'm going to replace, okay. So if I pick up a black ball, I'm going to go to another bag which has 3 white and 6 black balls. Okay. If I pick up a white ball, I'm going to go to another bag which has 4 white and 5 black balls. Is that clear?
Yes, ma'am.
Yes, ma'am.
Right. Now in this ball, again, I'm going to pick up, I can either pick up a black or a white ball. Is it clear? What is the chance with which
Yes,
I
ma'am.
pick up a black ball in from the bag too?
3/9.
9.
9, right? This is 3/9.
3/9.
Would you agree?
Yes, ma'am.
Yes,
Now
ma'am.
Yes,
here,
ma'am.
what is the chance with which I pick up a black ball?
5
5/9.
by 9.
5/9.
This,
5/9.
4/9.
now, let me define an event even. A white ball in second bag, okay? And E2 is a black ball in first bag, okay? What is the probability with which I pick up a white ball in the second bag? It could be either 3/9 or 4/9. And it depends on whether I picked up a black ball in the first bag or not. It depends on that, right?
Yes, ma'am.
Would
Yes,
you all
ma'am.
agree? Whereas
Yes, ma'am.
here, whether I get a head or tail in the second toss does not depend on whether I had a head or tail in the first toss.
Yes, ma'am.
Do you all agree?
Yes.
Yes,
Is
ma'am.
it clear?
Yes,
So
Yes, ma'am.
in this case, if E2 is the event of the outcome of the second toss and E1 is the outcome of the first toss, E2 is not dependent on E1. Whereas here, if E2 is getting a black ball in the second toss and E1 is getting a black ball in the first toss, E2 depends on E1. Would you all agree
Yes,
with
ma'am.
me? Because
Yes, ma'am.
whether I'm
Yes,
the probability of me getting, that is what is happening. So this is what we refer to as, so you can see here, B1 intersection B2 is, what is B1 intersection B2? It is getting black balls in both your first and the second bag. B1
Yes, ma'am.
intersection B2 is getting a white ball in the second bag given and a black ball in the first bag, and all these are the probabilities. Till here, is it clear?
Ma'am, if yes, ma'am.
Yes, ma'am.
If
Yeah.
the act of picking the balls from bag 1 and bag 2, are they independent?
What do you
Because we
mean
are
by independent?
like if we are picking a blue ball from bag 1 and we are picking a blue ball from bag 2, are
If
these
you
two
get a
events
black ball, no,
equivalent?
no, I'll explain the experiment. The experiment is pick up a ball from bag 1.
Yeah.
Okay. If it is a black ball, this one, go to bag 2 and pick up a ball from here. Let me put a bag 3 here to make it. If it is a white ball, pick up a ball from bag 3.
Yeah.
Okay. Now, suppose I had given you this experiment of 4 white and 4 black balls. 4 white, 4 black balls, 4 white, 4 black balls. This is similar to your tossing a coin experiment.
Coin
What is the
experiment.
chance of,
Yes, ma'am.
Yeah.
yeah. Whereas here you can see that if I pick up a black ball, I pick up a ball from a 3 white and 6 ball. If I pick up a white ball, so the probability of picking a white ball in the second thing is different from the probability of picking up a white ball in the second throw, given it was a black ball.
Yes, ma'am.
In the first one.
Yes.
Do you see that? So this explains that the events are picking a white ball in the second bag depends on whether it was a black ball in the first bag or a white ball in the second bag. It depends. Do you see that? Whereas here, whether it was a head in the second toss is independent of whether I had a head or tail in the first toss. I had the same chance.
Yeah.
Is it clear?
Okay. Yeah, sure.
Yes,
Is the idea clear?
Yes, exactly.
So that's right. So what the notion of conditional probability is, I want to know whether the chance of an event happening is dependent on other event happening or not. Okay. So the probability of E conditioned on F is nothing but this intersection of this E intersection F divided. So this is the chance of E happening conditioned on F to probability of F. Is this clear? This is how I define conditional probability, where probability of F is strictly greater than 0, not equal to 0. So far, so good?
Yes, ma'am.
Yes,
ma'am.
Yes, ma'am.
Yeah. So now if I use this formula, probability of E intersection F, I cross multiply, I get probability of E intersection F is probability of F into probability E intersection F. Conditioned on F. Okay. Now this is what the multiplication rule states, which says, see, remember the addition rule was probability of E union F, right? E or F happening. And there I had probability of E plus probability of F minus probability of E intersection F. Multiplication rule is probability of E intersection F. And what is that? From my definition, it is probability of F into probability of E conditioned on F. Till here, is it clear? Now, if you go back here to the probability tree, you can see now what is the probability of B1 intersection B2 happening? It is the, what is this? It would be probability of B2 condition B1 into probability of B1. Agreed?
Yes, ma'am.
Yes, ma'am.
What is probability of B1? That was 3/7.
Yes, ma'am.
Probability of B2 conditioned on this is 6/9.
Yes, ma'am.
Yes, ma'am.
So probability of B1 intersection B2, the way I can describe it is the probability of black ball in my first draw and a black ball in the second draw is given by this formula, which is probability of B1 into probability of B2 conditioned on B. Is this clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes,
So if this, so here, now again, what is probability of H2 intersection H1? From my definition, it will be probability of H2. Given H1 happened into probability of H1, but what was probability
Yes,
of
ma'am.
H1? It was 1/2. What is H2 given H1? Again, this is also 1/2.
1/2.
So I have a 1/4. Is that clear?
1/4. Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Now, when two events are independent, that is the conditional probability of an event A does not depend on B, then I know this conditional probability
of
is
A.
going to be the same as unconditional probability. This is the unconditional
ma'am.
probability of some. When A does not depend on B, probability of A conditioned on B is going to be the same as probability of A. Is this clear?
Yes, ma'am.
Yes, ma'am. Yeah, ma'am.
If two events are independent, probability of E conditioned on F, what will happen if E is independent on F? Probability of E conditioned on F is going to be the same as probability of E.
Probability of
Here,
E.
is it clear?
Yes.
Yes, ma'am.
Yes,
Right,
ma'am.
because it's not conditioned. Then in that case, what would happen here? This would become probability of E. Right?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
In other words, if two events, so the multiplication rule says that see, addition rule was about probability of union of events. Multiplication rule is about probability of intersection of events. Is
Intersection.
it clear? Right?
Yes,
So what
ma'am.
is the multiplication rule to say? For two events, it is given two events, probability of A intersection B is probability of A conditioned on B into probability of B. This is what it is for two events. So you can generalize it to multiple events, E1 intersection E2 intersection En, which is given by this formula here. Is this clear? See,
Yes,
till
ma'am.
this was for
Yes,
the
ma'am.
two events.
Yes.
Then I can now comes the notion of independence. Okay. Now, what is the notion of independence? If A and E is independent on F, what is probability of E conditioned on F? It is E only, right? So
Yes,
probability
ma'am.
of F into probability of E. So what this E is independent on F, then the probability of intersection is the product of probabilities. So two things which I want you, if two events are mutually exclusive or disjoint, what was probability of E union E2 when they are disjoint?
E1 plus E2.
Probability of E1 plus probability of E2.
So if they are independent, probability of E1 intersection E2 is probability of E1.
Probability of E1
into probability
multiplied
of
by
E2.
probability of E2.
This is addition, this is multiplication. So the addition rule for disjoint. Don't get confused between disjoint events and independent events. Is that clear?
Yes, ma'am.
Yes, ma'am. Yes,
Yes,
ma'am.
ma'am.
Okay. So two events that are said to be independent if probability of E intersection F is probability of E into probability of F. Okay, is that clear? Now for two
Yes, ma'am.
events, this is a necessary and sufficient condition. For 3 and more events, you have more things to worry about. Till here, any questions? Is this clear?
Yes, ma'am.
Yes, ma'am.
For an independent
please.
event, how will the Venn diagram be? How will they intersect? Like
They won't be, no, see, for example, let's look at head and tail, right? This is head. Let's look at a sample space where I have HH. So I'm having an event E1, okay, which is HH and HT, right?
yes,
This
ma'am.
is HT. This would be TH and TT somewhere. TH, okay, this is only TT. So this event here is both head and tail occurring together. Is it clear? Disjoint event, see, I didn't get your question for one thing. So if I go back to my Venn diagram of two events, I'm defining event to be HH, HT, E2 to be the event tail in my second toss, okay, TH and TT. I'm asking what is the probability of a tail in the second toss given that there was a head in the first toss. This is what I'm asking, right? What is the probability? So how does E1 look like? It is going to be HH, HT,
And HT in the
right?
intersection. Yes, ma'am.
This is TH, right? I'm asking, see, 1 second. E2 is, E1 is head in the first toss, which is HH and HT. Till here, is
HT.
it clear?
Yes, ma'am.
E2 is tail in second toss, okay, which is HT and TT. Is this right?
Yes.
The question I'm asking is, what is the probability of getting a tail in second toss given head was in first toss? This is the question I asked, right?
Yes, ma'am.
So this is probability of E2 given E1. Agreed?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Right?
Yes,
Which
ma'am.
is the same as half the so me getting a tail in the second toss is independent of whether I got a head or tail in the first toss. That's what I'm trying to say. Is it clear?
Yes, ma'am.
Yes, ma'am. Yeah.
Yes,
Right?
ma'am.
So that's what. So these are not actually mutually exclusive because HT is common to both of them. So two events independent, but they are not mutually exclusive. Is that clear? They are not disjoint. So that's why I'm saying do not confuse independence with disjoint. Is it clear?
Yes. Yes, ma'am. Yes.
Yes, ma'am.
Yes,
Okay.
ma'am.
Right. So the next important thing is the notion of what we say Bayes theorem, or the notion of, first we'll introduce what is called total probability. Okay. Now let me explain that with an example, and that example I'm going to take, I think I have. Suppose there are 3 manufacturing plants, A, B, and C. Okay. And all of them are sending the shock absorbers to a certain manufacturer. Okay. Now let A denote the event that the part comes from A. So what is the probability that any event, this one shock absorber comes from plant A? It is going to be 0.2, right?
Yeah.
Probability
Yes, ma'am.
any shock absorber comes from plant B is going to be 0.3.
0.3, ma'am.
And from plant C, it is going to be
0.5.
0.5. So what this means is, suppose I'm getting 100 shock absorbers. I pick up one shock absorber at random. What is the chance with it comes from plant B?
0.3.
It is 0.3. Right? Okay. Now, what we have is, not all of them are good. Every plant has a chance that their shock absorbers might be defective. Is that clear? Now, what is it saying? It is showing that the percentage of defective items produced by A, B, and C is 3%, 2%, and 1%. What does it mean? What is the chance that I have a defective given it is from plant A? What is the chance that a part is defective given it is from A?
0.03.
0.03, ma'am.
0.03.
Very good. What is the probability of D given it's from B?
0.02.
0.02, ma'am.
Probability of D given it's from C?
0.01.
Till here, is it everything is clear to you?
Yes,
all?
ma'am.
Yes, ma'am.
Okay, very good. Okay, so now let me write it this way. This is what is happening. I'm getting parts from A. I have 100 parts from A, from B, and from C. 50% from here, 30 from here, 20 from here. Out of these 100 items, I have something that is defective. Let that be the shaded thing. So I could have a defective from A, I could have a defective from B, I could have a defective from C. Is this clear?
Yes, ma'am.
Yes.
Now,
Yes,
would you
ma'am.
agree that I can write, if D is the probability or D is the event of finding a part that is defective, I can write this D as D intersection A, union D intersection B, union D intersection C. Can I write that?
Yes,
D
ma'am.
as D
Yes, ma'am.
intersection A, which is this portion, D intersection B, which is this portion, and D intersection C, which is this portion. Can I write it that way?
Yes.
Yes, ma'am.
Now, what do I know about D intersection A, D intersection B, and D intersection C? Are they mutually exclusive? Are they disjoint?
Yes.
They are disjoint, right? So
They are
what is the
disjoint.
probability of D? Probability of D would be?
Ma'am,
Probability
0.06.
of D. It would be probability of D intersection A
Plus probability of D intersection
D intersection B plus
plus
probability
probability
of
of
D
D
intersection.
intersection C.
Till here, is it clear to all?
Yes, ma'am.
Yes, ma'am.
Yes,
So the
ma'am.
probability of
Yes, ma'am.
defective is going to be probability of D given A into probability of A. From where did I get this? What is probability of D intersection A? By multiplication.
From multiplication rule. Yes, ma'am.
Right? Plus
Clear, ma'am. Yes.
probability of D given B into probability of B plus probability of D given C into probability of C. Till here, is it clear?
Yes, ma'am.
Now,
Yes,
do I know
ma'am.
what is probability of D given A? It is 0.03. I have all these items here. Is that clear?
Yes.
Yes, ma'am.
This is what
Yes,
we
ma'am.
refer to as the law of total
Total
probability.
probability.
Okay. So what is the law of total probability? It says that if I have E1, E2 up to say EK, and all of these are mutually exclusive and collectively exhaustive. So I'm having the entire things which I have written this way. Is that clear? So I know that why are they mutually exclusive? Can I have a part coming from both manufacturing plant A and B together?
No,
I cannot.
ma'am.
It can come either from A or B.
or from B, or from C.
Don't confuse independence with disjoint. They are different. Okay, right? And I have an event F. This event F is what? It is the defective item. I could have an item which is defective, which could come from A or B or C, right? Then this F can be written as F intersection E1, union F intersection E2, union. So I can write any event F as F intersection E1, union F intersection E2, union F intersection EK. Till here, all of you agree? And each one of them are
Yes,
disjoint.
ma'am.
Yes, ma'am.
So what is the probability of F? Pardon?
Ma'am, could you please tell me why they are not independent? We have considered them as
What do you
disjoint.
mean by see? They are independent in the sense that what do you mean by independent? If I choose from A, then what do you mean by independent? Independent in a probability sense would mean that what disjoint means is a shock absorber cannot be chosen from A and B simultaneously together. It can be either from A or B. I cannot have a shock absorber belonging to both A and B together. Is it clear?
Yes,
Okay,
ma'am.
ma'am.
Then in
So
this sense, how would we define independent event like we have defined the
yeah,
disjoint?
I'll tell you. See, what is an independent event is choosing a defective is independent of whether it comes from A, B, or C. That is not true here. The probability that a part is defective, okay, is dependent on whether it comes from A, B, or C, because they have different chances, right? Probability of a part being defective, if it is from A, is 0.03. Conditioned that it is from B is 0.02. Conditioned it's on C is 0.01. I don't have the same probability. It is conditioned. So probability that it is
Ma'am,
defective.
example, if we had 0. Ma'am, example, if we had the probability of 0.1, 0.1, 0.1, then it would be independent.
In a sense, yes, because the chance that you are having a defective and the probability of defective also should be the same as that. If probability of it being defective is same as probability of D given A, is same as probability of D given B, is same as probability of D given C, then it is independent.
Yes, ma'am.
When you say two events are independent, the probability of D is same as probability of D given A. It's just not 0.01, 0.01, 0.01 because probability of D is 0.2 into 0.01. It won't be the same. Do you get it?
Yes, ma'am. In this case, it won't be same.
It won't be, right?
Yes.
So basically, you're saying probability of effective is independent, and whether it is coming from A, B, or C is independent.
No, I'm not saying that. I say that the probability of, when do you say that D probability, D is an event that an item is defective.
Yes,
okay. Now, does that depend on whether it comes from A, whether it comes from B, or whether it comes from C?
No, ma'am.
Yes, ma'am, it does.
Yes, it does, right?
Yes, ma'am. Yes, ma'am.
Right.
Yes, ma'am.
So
Sorry, ma'am. Yes,
D
yes.
is it is not independent. Now, when would you say it is independent? If the probability of you finding a defective is same as the probability of defective coming from A, then you say it is independent of whether it's from A, whether it's from B, or whether it's from C.
Yes,
Okay,
ma'am.
ma'am. Understood, ma'am.
Okay. Yeah. So
Even
this
if
is,
ma'am, sorry to interrupt. Even if their probabilities are same, they are mutually exclusive.
what are mutually exclusive? No,
Ma'am,
see,
if they
even if the probabilities are same, okay, what does this say? The probability of you finding a defective given from A. But what is the probability of finding a defective in the entire thing? That would be 0.2 into 0.01 plus 0.3 into 0.01 plus 0.5 into 0.01, which is not equal to 0.01.
Okay, ma'am.
Got it? Because, see, imagine this. I have 100 things, of which 20 have come from A, 30 apples. Imagine 100 apples, okay? 20 have come from region A, 30 have come from region B, and 50 have come from region C. Okay? Is that clear?
Yes, ma'am.
Yes, ma'am.
Now I pick up an apple. I'm
Yes,
asking you
ma'am.
what is the chance of that apple being rotten or defective?
Ma'am, it depends on from which regions apple
Then
we have.
now, so that is what I'm saying. Is it independent of from which region it has come, or does it depend?
It
It
depends.
It depends.
That will explain to you whether it is a dependent event or independent event.
Yes,
Yes,
ma'am.
ma'am.
Now
Yes.
understood it very well. Thank you, ma'am.
Is it clear?
Yes, ma'am. Totally.
Yes, ma'am.
Ma'am.
So,
Yes.
how do we get that? We get it as probability of F is. So the same thing I can extend it to K items. Probability of F given E1 into probability of... This is what I refer to as the law of total probability. Okay. Now let's go back to this defective. If you don't like, let's take the apple case itself. Now I pick up an apple from these 100 apples. Okay. And I notice that it is rotten. I repeat, I pick up an apple from these 100 apples. I notice it is rotten. Now I'm interested in knowing whether it has come from A or B or C. What is the chance that... So what is given to me now? What is it I have noticed? I'm conditioning this one. I have noticed that it is defective. Agreed? I want to know what is the probability it comes from A. This is what I wanted to know. What was my initial probability? See, imagine I have these 100 apples. I pick up one apple. I'm asking what is the chance it comes from A. What is the chance it comes from A?
Ma'am, A 0.2.
0.2. Now I am giving you some extra information about that apple. And what is the extra information I'm giving about that apple?
Apple is rotten.
That it is rotten. That it is rotten.
So I'm asking the same. So this is what I refer to as prior probability. This is posterior. That is, I am asking you now what is the probability that it comes from A, condition that it is defective. Do you see the difference?
Yes, ma'am.
Yes, now again,
yes,
what would this be? This would be probability of A intersection D by probability of D. From our definition?
Yes, ma'am.
But what is this A intersection D? By multiplication rule? It is D given A into probability of A.
Yes, ma'am.
Multiplication rule.
Yes, ma'am.
And what was my denominator? It was D given A into probability of A plus probability of D given B into probability of B plus probability of D given C into probability of C, right?
Yes.
Yes, ma'am.
Yes, ma'am.
So this is what is called posterior probability, and that is what we have as the base rule. What is the base rule? It asks what is the probability of A1 conditioned on B. It is probability of A1 intersection B divided by probability of B, and B here I have given it as a total probability rule. Is this clear, please? How we have got the base rule? And that is what prior and the posterior.
Yes.
Is this clear?
Yes, ma'am.
Yes, ma'am.
This is about law of total probability and how we can apply this probability. And here it is about this one. Thank you all. Any other questions?
Ma'am, can you elaborate on that bookshelf question?
Disjoint events and independent events again.
Bookshelf.
Okay, let's go back to this. First let me do the disjoint and the independent events. Where was that? That was this. E1 intersection E2, right? Okay. Let me toss a coin twice. Okay, what are the outcomes? HH, TH and D.
TH,
Here is it clear? Right.
Yes, ma'am.
I'm defining E1 to be head on first toss.
HH
What
and
are the
HT.
events here?
HH and HT.
I'm defining E2 to be tail in second toss.
HT and TT.
Are E1 and E2 disjoint?
No.
No.
No,
HT
ma'am.
Not disjoint.
HT is common intersection.
Are E1 and E2 independent of each other? Is E2 independent of E1? That is, getting a tail in the second toss, does it depend on whether you had a head in the first
No,
toss?
ma'am.
No, ma'am. It does not.
Are they independent?
It will not depend, ma'am.
No.
Now do you get it? So events that are
0.5
disjoint
in
need
both
not-
cases.
Right. So you can, is this clear? They are disjoint,
ma'am.
but they are independent, right?
Yes, ma'am.
This is a very common thing is people get
Yes, ma'am.
Ma'am, can you
mixed with disjoint and independent.
Ma'am, if there are two
ma'am.
cases, E1 and E2, and like E2 is a null event, like the probability will always be 0. Can we say it's both disjoint and independent?
No, what define the event, no? What do you mean by null the event?
Null event means it is a
See,
impossible
for example,
event.
let me tell you tail in the first toss. Okay, instead of tail in the second toss, I'm talking about tail in the first toss. Okay, what is that? That is TT and TH. right? E1 and E2 are mutually exclusive. I cannot have a tail and a head in the first toss.
Ma'am, TH will not come, ma'am.
Tail in the first toss.
First toss.
Okay.
I cannot have a head and a tail in the first toss, right?
Yes, ma'am. Yes, ma'am.
Yes,
Now
ma'am.
they are disjoint, right? E1 and E2 are disjoint.
Yes, ma'am.
Yes, ma'am.
Disjoint.
They're mutually exclusive.
E2 is a null event, right? I cannot
Yes,
have a
ma'am.
tail and a head in the first toss, right?
Yes, ma'am.
Got it? So E1 intersection E2 is null. Is it clear?
Yes, ma'am.
There was what is the bookshelf question? Somebody asked about a bookshelf question.
Can you explain the Bayes rule, the denominator part?
See, the denominator part. Okay, see now
Yes.
I'll do it with two events.
And
Suppose
even
I
numerator
have two
part.
events, E1 and E2. Okay, E1 and E2 are mutually exclusive and collectively exhaustive. So E1 union E2 is my sample space, and E1 and E2 are disjoint. So far, so clear? Is this clear?
Yes, ma'am.
Yes, ma'am.
Consider an event F. F can happen. So I can write this F as F intersection E1 union F intersection E2. Till here, is it clear?
Yes,
So
ma'am.
let's look at this. I have this apples coming from A and B. I can have a defective apple. Okay. So imagine 100 apples. Okay. 40 are from A and 60 are from B. I have defective apples, which can be both from A and from B. I can write F, or I can write D as D intersection A union D intersection B. Till here, is it clear?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes,
So
ma'am.
by my addition rule, this would be probability of D
D
intersection A
intersection
plus
A
probability
plus
D
D
intersection B.
inter B.
Right?
Ma'am, if two events are mutually disjoint, does that automatically mean that they're independent events?
No, that's what I meant, right? No, they need not
Okay.
be, right?
All right.
Okay. So here, this is probability of D given A into probability of A. How did I get this? This is from the definition of conditional probability and multiplication rule.
Yes, ma'am.
Yes,
That's
ma'am.
probability of D given B into probability of B. So this is my probability of D. Till here, is it clear?
Yes, ma'am.
Yes, ma'am.
This is what I call the law of total probability. And this is what I can extend. If I have A, B, C, I'll have a D given C into probability of C. If I have an A, B, C, D, I'll have a D given D into probability of D. Till here, is it clear?
Yes,
Ma'am,
Yes.
where
Yes,
to
ma'am.
use this rule, ma'am, in question?
Which question, ma'am? Anything. In this question, you can see that it is used, right? This is what is the probability that a randomly chosen thing would be defective. I want what is the probability of D. First one is law of total probability. The second one is what is the probability that it came from A given that the part was defective. So I'm asking what is probability of A given D. Here I'm asking what is probability of D. Is it clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. So once I get what is this probability, the next thing which I wanted to do is, okay, given. So now I am asking what is the probability it comes from A given it is D. This is nothing but probability of A intersection D divided by probability of D from a conditional probability formula.
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Now what is the numerator multiplication rule? It is D given A into probability of A.
Yes, ma'am.
Denominator, this would come. So that is what my Bayes rule says. That is exactly what is my Bayes theorem. Is it clear?
Okay,
Ma'am, if there is an event that getting head and tail both in the first toss, that would be null event. And a second event is there that getting head, which would be 0.5 in first toss. So can we say that the two events are both discrete and independent?
I can't understand what you're saying.
Means the first event is getting a head and tail both in first toss, and this can
cannot
never happen.
happen.
So it will be 0 probability. Second case is getting just an head, so that would be 0.5. So can we say that these two events are independent and discrete both?
How are they independent? No? First of all, the event of getting a head in the first toss, okay, right? And you're defining getting a head and tail. It is, first of all, it's a null event.
Like by that formula, that intersection is equal to
A given B is probability of A intersection B, provided probability of B is greater than 0. You don't condition it on a null event.
I was saying that we had a formula of independent.
Condition anything on a null. Forget about formula, ma. You do not condition any event on a null event. That's what I'm trying to say.
Ma'am, A and B should both be defined, no? Then we will apply the formula and everything.
For this formula, to get a probability of A conditioned on B, I need probability of B to be greater than 0. Okay.
Hello, ma'am. I have sent you a question. Can you have a look on that?
Which one?
In the chat, in your chat, I have sent you.
There are too many chats. So what is the question?
Okay, ma'am. I'm sending it once again.
Can you?
No. I won't answer specific questions.
Yes, ma'am. I have sent you.
I will not answer specific questions.
No, not specific question, ma'am. From your slide itself, ma'am, that bookshelf question. Can you please explain it?
No, this is a specific question. Answer is incorrect. Accepted answers. I'll not answer.
Ma'am, I have just a small doubt here. In the note, it is written that everything is. Can you please take it? The note part here, the given.
Which note part? No, I think I will address the bookshelf question. I'll not answer anything from the textbooks, okay? From the assignments or anything. Yeah, what about the bookshelf question? There was some bookshelf. Yeah.
Ma'am,
What is the
after
question
the
here?
6 and
Yeah, here, this is the bookshelf question.
Yeah, ma'am. That arrangement, how to solve? Like
See, I have 8 different books. I have 8 different books. So I have 8 distinct books. Okay, I want to arrange 5 books on the shelf. How many ways can I do it? I have 8 people and I want to arrange 5 people. How many ways can I do it?
8C3 into 5 factorial.
8P4. That will be nothing but it's a permutation, right? If I want to arrange, it will be a permutation, right? But if I just want to choose 5 people, it's going to be a combination. That's it.
Ma'am, what if there are 2 bookshelves?
So what is the question? Tell me what if there are 2 bookshelves? So what is the question? You want to arrange 5 books on 2 bookshelves?
Yes, ma'am. That one I can't get over it. I tried manually, even I can't think of.
What is the question?
Like if there are 5 distinct books, and there are 2 bookshelves.
8 books, and you have to arrange 5 books on 2 bookshelves.
Yes, ma'am.
So you have to choose only 3 books. So apply the basic rules of counting. So I can have 3 books here, 2 books there, 2 books here, 3 books here, and that is how it would be. Okay.
Okay.
Right?
No formula is applicable there. That's C and P on.
No, see, these formulas are, don't please get into, I understand formula is very, very important. Okay. But first understand what is the question that is being asked before you deep dive into a formula immediately. Okay. That's all I'm trying to say. Okay. So sometimes you might require multiple use of the formula also.
So we have to make cases and then simply add them.
You add it add or multiplication again depending on the context of the problem. If it is sequentially done, then it might be multiplication and multiplication or addition. See, there is no
in this respective case, it will be
answer.
added. In this respective case of 2 books,
A
it will be added.
or B. I cannot put a book on A and B at the same time, right?
Yes, ma'am, it will be added now then.
So that's what I'm saying. So depending on the context, so can I give you a formula for this? No. depending on the context of the problem, you'll decide on what to do. Is it clear? Yeah, I think, Prashant, I stop here. It's already 10 minutes past. Okay.
Yes, ma'am. Yes, ma'am. We can stop now.
Okay. The only thing, Prashant, from next time, in case you're doing it, let's restrict it only to people who have the roll numbers. Okay.
Yeah,
And
ma'am,
let
sure, yeah.
them, I think before I stop, I want to apologize for being rude at the beginning of the session. Usually I don't lose my thing, but I think some people were just disrupting it. I think all of you would agree with me. That they were disrupting.
Yes, ma'am. Surely, ma'am. No issues
Hello,
regarding
hello, ma'am.
I'm
Hello,
sorry.
ma'am.
I didn't mean to be rude. I didn't mean to be impolite. But
You were not rude.
I think
You were not. You were not. You
the
were not. You
initial part of the
rude or
lecture, they were
anything.
really disrupting. Okay. I did not mean to be impolite. I really respect students a lot. Okay. So I'm sorry if I came out to be rude.
No, no, ma'am.
or I-
Don't be sorry, ma'am.
No, ma'am. You weren't rude, ma'am.
Say sorry, ma'am.
Thank you all.
Actually,
Thank
we
you all.
are sorry.
Hello, ma'am. Hello,
Not an
ma'am.
issue. Yeah.
Hello, excuse
Yeah.
me, ma'am. As you said, only the registered email, ma'am. I have qualified in the qualified, but haven't got the email ID yet. So if another session will happen, I won't be able to join. So how's it fair?
So you please
Yes,
contact
ma'am,
the
no
administration
problem.
about it.
They have said they will give after the September.
Okay, lecture. We will
September
take care
exam.
of this. Okay, do not
Yeah,
worry.
yeah. I think Prashant will take care of it. Okay.
Yes.
And
Yeah.
this is not the forum, right?
Yeah, that's
Okay.
because some person has shared the link and password on YouTube.
No, I think from here onwards, you'll do it only for this is see. I'm not saying that this has to be exclusive or something. I think they were very clearly troublemakers, and it just disrupts the entire session. Okay?
Yes, ma'am. It's our privilege to have lectures from IIT professors directly, ma'am. So we appreciate it, ma'am. Thank you so much, ma'am.
We appreciate
Yes,
it.
ma'am. Thank you so
all.
much.
Thank you all. Thank you
Thank
all,
you
and good
so
night.
much,
Thank
ma'am.
you, ma'am. It was a
Once again, I
wonderful
apologize if I came out to be
Ma'am,
very
don't
rude in the
apologize
beginning.
me.
Please don't apologize.
Don't
Thank you, ma'am.
say that, ma'am. Thank you, ma'am. Thank you, ma'am.
Thank you, ma'am.
Thanks for the
Thank you,
session.
ma'am.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Good night. Good night, ma'am.
Thank you,
Good
ma'am.
night.
Thank
Good
you,
night.
ma'am.
Good
Good
night.
night, ma'am.
Good night, ma'am.
Madam.
Bye, ma'am.
Thank you.
It's our honor, ma'am.
Bye bye.
Good night, Prashant sir. Good night, everyone.
Good night, Prashant.
Totally acceptable, ma'am. Thank you. Good night. Have a great day.
Hello, Prashant sir.
Hello, sir.
Hello, Prashant sir.
Yes.
I have sent you a question in a chat box. Can you please look into it?
Sir,
Okay,
hello.
we can see.
Prashant sir,
But I
where we
think.
got the PDF?
Hello.
Okay, so actually these PDFs are already on supplementary content. You can find under lecture
No,
PPTs.
sir,
Okay.
just check
So
the note part, sir. In the note part, it is written all keys are identical. If all keys are